Hello and welcome to another lecture. Today we will explore the fascinating world of traditional building techniques from Central Asia. My name is Bono and I'm a researcher in the VEGERA project. As being an architect, I have dedicated my research to uncovering how traditional techniques can shape a future of eco-friendly, low-cost, low-carbon housing that is both culturally and environmentally sustainable. Our mission in the VEGERA project was to design forward-thinking homes by leveraging local knowledge, materials, and traditions. We aimed to create houses that are CO2 neutral, affordable, and technologically simple, all while reflecting the rich heritage of Central Asia. Throughout this episode, I will share insights into traditional architecture, its sustainable principles, and how we reimagined them for the modern era. Did we achieve this? Stay tuned to find out. Central Asia boasts a remarkable architectural heritage shaped by its diverse climates, rich history, and deep cultural traditions. From adobe homes to intricate courtyard designs, these structures were built to harmonize with their environment. They were not just shelters, they were also systems that balanced functionally with cultural identity. By studying these designs, we uncover principles that are surprisingly relevant to today's global challenges. Let's look at the broader picture of sustainability in the building sector. Globally, the construction industry is responsible for 39% of carbon emissions, 11% of which comes from embodied carbon, the emissions tied to extraction, production, and also transportation of building materials. Reducing these emissions is a critical challenge. Here is where traditional materials shine. First, rameters, and the other one is straw bales. Rameters are widely used materials in traditional buildings. Ramet earth has an embodied carbon footprint of just 0.014 kg CO2 per kilograms compared to 0.35 and 0.50 kg CO2 per kilogram for cement concrete. Straw bales, a renewable resource with excellent insulation properties. Straw bales offer an R value of R33 to R50, significantly outperforming conventional fiberglass insulation. Locally sourced materials not only lower carbon emissions but also boost local economies and generate more jobs compared to imported alternatives. Traditional construction methods in Central Asia offer valuable lessons in energy efficiency. There are lots of techniques, but two are very important and very well spread. First is Pahsa, or adobe house, built with natural earth materials. These homes are excellent at maintaining indoor temperature, reducing heating and cooling energy needs by up to 30%. Second, Sinch, or in German Fachwerkhouses, combining wooden and earthen materials. These structures feature passive cooling systems which reduce reliance on modern energy-intensive air conditioning. More techniques comes here, for example, seasonal adaptations. Homes were often advised into winter and summer living areas, maximizing energy efficiency and comfort throughout the year. And also courtyard designs important. For example, central courtyards acted as natural cooling reservoirs in the summer, stabilizing indoor temperatures. One of the most fascinating aspects of traditional Central Asian architecture is its integration of astronomical and climatic insights. Here come some of the points. First, orientation. Second, sun pass and glare control. And third, climate-specific adjustments. Orientation. Houses were oriented to maximize southern sunlight during winter, providing natural heating while minimizing summer heat exposure. And sun pass and glare control. The way a house is designed can help it use sunlight effectively. For example, in winter, homes can be positioned to let in sunlight from the south to keep the space warm. In summer, features like roof overhangs or shaded windows can block direct sunlight, keeping the house cool and glare-free. This thoughtful design ensures comfortable lighting and temperature all year round. And the last point could be climate-specific adjustments, which, for example, the buildings in Tashkent were designed to suit the local climate. They often had courtyards that worked like natural cooler, storing cool air and helping to keep the houses comfortable in the summer. Basements served a double purpose as storage areas and natural air conditioning spaces, providing a cool environment during hot months without using extra energy. These features demonstrate how builders of the past intuitively understood energy efficiency long before modern technologies. Now let me share how we brought these traditional techniques into the modern life throughout the VEGERA project. We analyzed 3 types of Uzbek house typologies using advanced simulation software to measure energy efficiency and CO2 emissions. Our findings were compelling. First, energy performance, second, CO2 emissions, and third, cultural integration. Energy performance houses that incorporated thermal mass and natural ventilation systems used significantly less energy. CO2 emissions, the model house inspired by traditional design, consistently produced lower emissions than conventional homes. And cultural integration, by integrating elements like courtyards, wooden walls with straw bale installations and passive solar designs. This project created homes that were both sustainable and deeply rooted in local heritage. By integrating local materials, passive design principles, and cultural aesthetics, we developed a housing prototype that aligns with modern needs and while preserving heritage. In conclusion, the future of construction lies in bridging traditional wisdom with modern technology. Central Asian architecture provides a blueprint for creating homes that are energy efficient, culturally rich, and environmentally sustainable. So we must promote the use of locally sourced regenerative materials. We must preserve and modernize traditional techniques. We must encourage governments to invest in research and pilot projects such as VEGERA that integrate heritage and sustainability. Sustainable construction isn't just a technical challenge, it's a cultural responsibility. By embracing these principles, we can reduce carbon footprint, support local communities, and ensure a better future for generations to come. I encourage you to think about how we can incorporate these principles into your own work. Sustainability is not just a choice, it's an imperative for our shared future. Thank you.